Hi everyone, my name is Daniel Kmak and I work in developer relations at Nervos network. Today let me show you how you can use React.js and Web3.js to deploy your Ethereum application to Nervos Layer 2. We are also going to use Hard Hat as part of this, and we will be using JavaScript in this example, not TypeScript. We have other examples using TypeScript already, but people were asking specifically for React.js, create React app and JavaScript example. So this is what we will be going through today. So we are going to use a Nervos EVM starter repository, which is specifically created for the purpose of this tutorial. And this is the recommended way if you want to use React.js, create React app, create React app, Hard Hat, Web3.js. That's basically it. Also, the agenda for today is really to take this starter repository, which is right now using just like very simple smart contract, where you can just like set integer value and read this value, and we will change the smart contract that is used in this application to some ERC20 token. So this is what we are going to do. So first thing is you need to go to this repository here and clone it on your file system. Make sure you already have Node.js installed. So let me go to terminal. Then you need to clone this repository. All right. Alright, so I recommend now you open this repository in your Visual Studio Code editor or any other editor that you are using. Alright, and then you just basically need to follow the README. So first things you need to do is you need to install yarn dependencies. So let's do this by using yarn command. Yarn is a shorthand for yarn install, so you can use both of these commands. Alright, it looks like our yarn dependencies were installed, so now let's try compiling our smart contract. As you can see right now, we are just using simple storage smart contract. It's really a simple storage. It just has two methods, get value and set value. So we need to compile it, so we have bytecode and ABI, which will be used for the deployment of this contract and as well interacting with this contract, because ABI is basically an interface to interact with this contract. So let's run yarn compile. Alright, so it seems compilation succeeded on my machine, and in the directory source artifacts, I can see the ABI of my contract. That's perfect. So first time you run this command, and if you don't already have Solidity compiler with the version 0.8.4, then Hard Hat will install it for you. So it might take a little longer, but it will work. So right now, after we compile this contract, let me show you what you can do in this Nervos EVM starter repository. So if you want, after you compile your contract, you probably want to deploy it. And you have two ways to deploy this smart contract. So first, and maybe simpler way, is to just, in the scripts directory, you will see deploy MJS script. MJS extension basically means it's ES module, which is like the the modern version of structuring your JavaScript code in Node.js. So if you open this file, all right, actually the name I hear is wrong, so let me just rename it to the simple story JSON. And yeah, we basically take the compiled smart contract. Here we read the JSON file, and then we use Web3.js to deploy this contract, and we output the address. Everything here is using source/config.js file, and in the config file you can see that we are using testnet RPC provider. So if you go to package.json, you will see that you have deploy script specified there. So it's a very simple script. It just runs the script, the deploy MJS script in Node.js runtime. But yeah, let's type it. So let's use yarn deploy command and see if it works. Okay, we get our smart contract address, so it seems like the script is working. So as you can see, you can use Web3.js in your Node.js scripts. It already has Nervos layer 2 provider configured. So yeah, you just basically need to put your contract in the contracts directory, and then you can reference it. Then after you compile the contract, you can reference it in your Node.js scripts. But that's not everything. This repository is using React.js. So if you look in the README, you will see it's a typical README of Create React App. So if you want to start your React application, just run yarn start. So I'll do it in the terminal. Our application is starting. All right, here's our application. So what you can do right now is you can either deploy the simple storage smart contract by using deploy contract button, or you can take the address from the Node.js script that already deployed the contract. So I'm going to use the latter, and right now I should be able to get stored value from the smart contract. And you can see it works. Now let me try changing it. So this is a React.js application which is using Web3.js. Yeah, that's basically everything. All right, let's check the value now after we send a transaction. And we can see we have new value, so it means that sending transaction worked. Yeah, as I said previously, you can also use deploy contract button and it will deploy the contract in your browser. But yeah, for now we're good. So let's take a look at app.js file. So this is your React application. So it has already, so the Nervos layer 2 provider is already configured. As you can see, it is also using the value from config.js file. And yeah, it's using simple storage contract right now. And we are going to change it to use ERC20 token. But one more thing that you can do is, if you want to use Nervos token integration library which provides some handy functions for you, like for example translation between Ethereum address and Polyjuice address. Polyjuice address is a representation of the Ethereum address on Nervos layer 2 chain, so basically in smart contracts world. So you need to remember that smart contract see your Ethereum address on Nervos layer 2 as a different address, and this address is a Polyjuice address. So yeah, you have address translator, which is able to transform between Polyjuice address and Ethereum address. But also it can give you a layer 2 deposit address to use in the bridge. So this function is commented by default, but you can see it's working if you uncomment it and then you call it somewhere. So for example, it's just for like demonstration purpose. So let me put it here in one of the use effects functions. Let's open the console and you can see that the layer 2 deposit address was correctly computed. So I can remove it now because we don't need it at this point, but you can use it. It's configured. And one of the things that you can see is if you take a look at the scripts in this repository, it's using something called React App Rewired. And like, why is that? So this is because one of the dependencies should be processed with more advanced Babel configuration. So we are overriding default create React app config, and we basically add optional chaining Babel configs. So because if you use create React app, maybe you don't know about this, but you have a different Babel config for processing your application code and different for processing your dependencies code. So this is basically for using more advanced dependencies Babel config. So all the dependencies will work correctly in your React application, as you can see here. So right now, let's change the smart contract to some ERC20 token. So I recommend for basic stuff, for the fundamentals of blockchain, you probably can find many of the contracts that you use or you want to use in Open Zeppelin contracts repository. So example of that is ERC20 contract or ERC721 NFT smart contract. So let me install this repository. And after this installation is complete, we will import it somewhere in our contract. So let's change the name of our contract to my token, for example. And let's import the contract that we want to use. So I want to use ERC20 contract. All right, path should be good. And let's make sure that our my token contract implements ERC20 or inherits its properties. And in the constructor, we are going to mine some tokens. By taking advantage of mined function. So let's mine 7,777 to the creator of my token contract. So we changed our smart contract. Right now we need to run yarn compile again. All right, we have a problem here because I incorrectly inherited from ERC20 contract. So I basically need to make sure my constructor is correct. So the constructor of ERC20 in OpenZeppelin implementation takes 2 parameters. So I need to make sure that I also have these parameters. And let's try running yarn compile again. And right now it worked. If we go to source artifacts, we can see we have my token ABI right now. So first, let's try to modify our Node.js script to deploy this contract instead of deploying simple storage. So we need to modify file that we are importing. So we need to make sure we import my token artifact. And when we are deploying this contract, we need to pass 2 values, name and symbol. So let's modify our deploy call. Okay, I think that should be it, but let's try deploy now. All right, it seems that deploying our token contract worked using Node.js script. So what we can do right now is we can modify our React application, which right now didn't even start because we modified the contracts. And we want to modify it so maybe it will display balance of our account. So let's go to app.js file, and here we need to import my token instead of simple storage. All right. And right now, when we get stored value, let's make sure we get balance of our account. So get balance of account, of current account. So instead of calling method get, let's make sure we call balance of function, and we pass here our account. And let's see if it works. So first of all, remember to copy the address of your token contract and use it in your React application. And now let's try calling balance function. Alright, and it reads 0 for now, and let's try to find out why is that. So if we are using balance of method directly, then we should be using Polyjuice address instead of Ethereum address, because as I said, in the smart contract it was saved using the balance was saved using Polyjuice address. All right, anyways, let's stick to using balance of method, but let's make sure we pass Polyjuice address here, and let's see what happens. So this React application is using hot reloading. So if we call getBalance again, then we get correct value. What we could do is we could make sure that we have a balance method here, that instead of taking parameter with the address is using message sender, then everything would work just fine. We can see that the transfer method is actually using that. But yeah, for the purpose of this demonstration, I think we're fine because you have translation to this Polyjuice address. So yeah, I think that's it. It was a very simple demonstration how you can use Nervos EVM starter repository to work on your application using Web3.js, React.js, Create React App, and Hard Hat. So happy coding, and if you hit any problems, make sure to go to Nervos Discord channel, to Gitcoin Hackathon, to Nervos Network server, to Gitcoin Hackathon channel, and feel free to ask questions there. We are there to help. Right now, the Gitcoin Hackathon is in progress, so I hope building your application is going really well, and I wish you good luck here. If you have any requests, anything you would like to see we talk about next, any more demonstrations, more repositories that you would like to use, feel free to also go to our Discord channel and ask us if we can do if we can create such demonstrations. There's actually one more thing. So I recommend, if you are looking for something different than what was demonstrated today, I recommend going to the Gitcoin tasks that we had and going to task number 7. So if you go to more examples section, then I keep this section updated. So we also have ethers.js plus hardhat plus typechain plus TypeScript starter repository, which is using right now chaining smart contracts, but you can replace it and use anything if you prefer to use TypeScript and ethers.js. We also have a couple of more repositories. So yeah, I think that's it. Happy coding, and make sure to visit our Discord. Goodbye.